Okay, so we've been asked to find this and its principal value. So when we have a number raised to a complex power, then this is defined as e to the log of this. So the log of this is 2i log 1 minus I. Okay, so just 1 minus I, well, okay, we can evaluate this. So we've got e to the 2i log 1 minus I, seems familiar. It's modulus root 2, and the argument of this is minus pi by 4, so it's going to be plus I times minus pi by 4. Looking ahead, rather than add 2 pi n, I'm going to subtract 2 pi n. Why am I doing this? Just because I know I've got I times I, which is giving me a minus sign anyway. This makes the final expression look nicer. So I've got it's the minus 2 pi n there. And I've got all of this is in brackets as well. Another bracket at the end there. So I just expand everything and see what I get. So I get. So let's get the real parts first. So the real part inside this first. So the real part is going to be I times I gives me minus 1. So I'm going to get e to the pi over 2 plus 2 pi n. And the imaginary part is just going to be 2 log root 2. Now log root 2 of course is half log 2, so basically I can put the 2 inside here and just get log 2. So I end up with this times e to the I log 2, and that's this is maybe a funny thing to leave like this, so I would normally simplify it and write it like this. So I'd have take out a factor of pi, and I've got half plus 2n times pi, and then if I expand this, I've got using Euler, I've got cos of log 2 plus I sine of log 2. Now asked finally for the principal value. Principal value you get just from setting n equals 0. So principal value is e to the pi over 2 times cos log 2 plus I sine log 2. I should mention another way of doing this question, maybe a cleverer way, is to notice that I can write this like this, and then say, well, 1 minus I squared, what's that? Again, if you think of it in polar form, you realize this is length root 2, so the square is going to be length 2. This is pointing in minus pi by 4 direction, so squaring it, you double the argument, so that gives you minus pi by 2, which is just minus I. So in fact, this thing here you can actually do in your head and say, okay, it's minus 2I to the I. So that's maybe something which is easier to start with. Then you can write e to the I log of minus 2I, and then do something similar to what we've done here. This maybe is a quicker way of doing it.